Good morning. In today's session, we have to study about different types of voltage regulators and their working principle. We will wait for other students for 1 minute. So we are using voltage regulator that can be used to regulate the voltage level. When if we are giving the steady state voltage, just wait for me. Okay, so what we are saying here, if we are using the voltage regulator, we can convert DC voltage into a DC voltage, or we can convert AC voltage into a DC, which will have fixed amount of voltage at the output. So here, when we are giving the steady state condition at that time, if we will require the reliable voltage level at that time, we can use the voltage regulator because it will give us constant amount of voltage irrespective changes in the input voltage, or there will be change in the load condition. Because when we are using the voltage regulator at that time, we will use some parameters that can be used with respect to the voltage regulator, like line regulations, load regulations, temperature stability. It means what? Irrespective of changes in input voltage, changes in load condition, or we are changing the temperature, at that time also we will get the constant output voltage. That's why we are saying here, if we are using the voltage regulator in irrespective of any changes at the input, by using the voltage regulator, we will get the constant amount of voltage at the output. That's why we are using voltage regulator, which can act as a buffer for protecting the components from the damage. And a voltage regulator is a device which uses negative feedback loop, because if you see the circuit diagram for the voltage regulator, we are using their control circuit. In that we are using the amplifier, and we are aware about the amplifier will use the negative feedback. That's why we can say voltage regulator will use the negative feedback control loop at the block diagram of the voltage regulator. You can see here, this is the block diagram already we have seen. Just see what we are doing here. We are giving the unregulated voltage, and we can convert that voltage into a regulator by using the comparator circuit, which will compare our feedback output voltage with respect to the reference voltage, and we are giving the reference voltage to compare. And if we see the circuit diagram for the voltage regulator, we are giving the reference voltage by using Zener diode, because we know Zener diode will work in a reverse biasing condition, and it will give us constant amount of voltage. That's why we are using as a reference voltage. So we are aware about there are different types of voltage regulator. Already we have studied about the linear. In today's session, we have to see switching. Okay, so what we are saying, in linear voltage regulator, we can use, in linear voltage regulator, we will get constant output voltage by converting unregulated input voltage into a regulated. And if you see linear voltage regulator, again, it will be divided into different types, like series and shunt. In series, we can use Zener diode. In shunt, we can use BJT or any type of transistor. Then we have seen fixed and variable IC voltage regulator. Fixed means what? If we are having the fixed IC regulator, it will give us fixed amount of voltage. And if we are using the variable, it will give us variable output voltage at the output. Variable voltage. So you can see here what we are saying. Linear is divided in series and shunt, already we have seen. So in today's session, we have to study switching regulator. So there are the three types of switching voltage regulator. So you guys are aware about the switch. It means what? if we are making turn on switch, or if we are turn off the switch, at that time there will be get constant amount of voltage. It means what? By making the switch on and off, we can regulate the output voltage. That device we are calling as a switching voltage regulator. So in switching voltage regulator, there are three types: step up, step down, and inverter voltage regulator. So linear voltage regulator, what we are saying, if we are using the linear voltage regulator, we will get the constant output voltage irrespective of changes in the input. So if you see here, we can use transistor or we can use the zener diode. So linear regulator acts like a voltage divider, because here we are supposed to regulate whatever input you are giving at the input. But if we are using the voltage divider, what will happen? That voltage get divided, and whatever amount you will be required at the output, you will get. So we are using voltage regulator as a voltage divider circuit. And if you see in ohmic region, we are using the FET, because what we know, if there is a ohmic region, output value of current increases with respect to the voltage linearly. How it will increase? Linearly. That's why we are using FET, that will be in the linear or the ohmic region. And if you see, the resistance of voltage regulator varies with load resulting, but it will give us the constant output voltage. And if you see, there are some advantages of the linear voltage regulator. These are like, it will give us low output ripple voltage. It will give us low electromagnetic interference, because here we are using the inductor. Because what we are saying, when we are using the linear voltage regulator, at that time we are using the FETs. So it will give us low output ripple. It means what? There will be less amount of harmonics, error, and it will give us fast response time to the load or line changes. It means what? Irrespective of the changes in input, it will give us constant amount of voltage at the output. And there are also some disadvantages, like the circuit will require large space, because if you see here, we are using zener diode, here we are using resistor, here we are using at the output voltage divider circuit. So you will require again resistor. Again we are using here FETs. That's why we can say it will require large space, and as here we will require large space, it will take more amount of power, and as it will take more amount of power, heat gets dissipated, मतलब heat generate होगा, and as heat gets generated, we will require to compensate that heat sink. That's why this is the disadvantages for the linear voltage regulator. And if you see, its efficiency is also very low. Voltage we cannot increase above the input. This is the main disadvantages of the linear voltage regulator. If you see already, ये जो circuit diagram है हम देख चुके हैं. What we are saying, if there is a series voltage regulator, control element will be in series with input and output. This is the block diagram. What we are saying, if we are using the voltage regulator, at that time it will uses the variable element that will be placed in series with the load. Already ये देख चुके हैं हम series voltage regulator. What we are saying, we are using here this as a control element, and you can see this control element BJT will be in series with load, and it will be in series with the input. What about shunt? What we are saying here, we are making the shunt connection. So shunt voltage regulator works by providing the path from supply voltage to the ground through variable resistance. Because in shunt voltage regulator, we are using the variable resistance, or we can say we are using the rheostat. So the current through shunt regulator is get diverted from the load, and it flow usually to the ground, making this form usually less efficient than the series regulator. If you see, already we have seen about the disadvantages of series. What we are saying, it is not that much